Namaste. Welcome to this session on MaxApp Scaler. Now, MaxApp Scaler is also not so much useful when we have outliers in our data because how do we now what is actually meant by MaxApp Scaler? It is scaling by the maximum. This max is maximum, ABS is absolute, and scalar is the scalar. So we are basically for each feature X we are calculating the maximum absolute value of that feature. So I've changed the data here a little bit. I have infused a little negative values here. But if you check now, what is the maximum value in this data? It is minus 49 because now we are concerned with the absolute of the maximum value, right? So we have minus 49, but maximum is 49. So this is the highest value. So how do we calculate the maximum value, maximum scaled value? For that, we'll simply divide each observation by the maximum of the absolute value. So simply just what we'll do is we'll say minus 5 divided by 49, 10 by 49, 12 by 49, minus 14 by 49. Similarly, minus 49 divided by 49. So we'll get a minus 1. Okay, so this is how MaxApp Scaler works. So there's nothing more to it. Now, if you would have guessed, if we have a huge outlier of 120 here, then we would be dividing each observation by 120, right? So that would shrink our data to very small values as well. So hence, it does not work very well when we have outliers in our data. So that is also one thing to keep in mind. This is the same before scaling, and after scaling we see the minimum value. If you just think about it, the minimum and maximum values for MaxApp Scaler will always be between minus 1 and 1, because you see the minimum value is minus 1. We can't go beyond minus 1 because we are simply dividing it by the maximum value, which is 49. Now if we have, so minus 1 is the minimum value. For the maximum value, for example, if I had a data of 100, okay, the plus 100, so the maximum value now will now become 100 plus 100. So 100 divided by the maximum value of 100 will give me 1. So maximum value will be 1, and we can't go beyond 1. So basically we can't go beyond 1 and can't go beyond minus 1 as well. So the value range will always be between minus 1 and 1. So that is what we see here. For this proline, it is going between 0 and 1, and for alcohol it is going between 0.7 to 1. Okay, so this is the distribution plot. Now after applying MaxApp Scaler on both of these, they are not on the same scale. They are on similar scales, but they are on different scales even after scaling. So this is not a good scaler to use, but you can try your luck when doing a modeling, whether it works for your model or not. Now we look at a practical implementation on a Jupyter notebook. So I've imported MaxApp Scaler from sklearn.preprocessing. So this sklearn.preprocessing is holding all my scalars and transformers. So I have now also imported all the models that I'll be using. Then my dataset fetch California housing. Then I have segregated my data into X and Y here. Then I look at my X. These are my X values. Now it also has latitude and longitude, but I do not want those. I simply want to ignore these two columns. So here I'll do x is equal to x dot ilog, give me all the rows, and for the columns I want all the until minus 2 columns. Okay, so my y is my median house value in each block. So all of these rows are different blocks in California. Now if I check my x head, they don't have latitude and longitude. Now if I plot my data on MaxApp Scaler, you will see what happens. Now the data is between 0 and 1 for this particular variable. And also you see the distribution has not changed a bit. It is the same distribution as before. So for each of the variables, it is not changing anything at all. See, it is the same. So hence, scaling MaxApp Scaler doesn't have any effect on the output distribution of the variable. Okay. So now I've split my dataset into training and testing set. Now I'll do MaxApp Scaler here. Now I'll check my accuracy using on k nearest neighbors using MaxApp Scaler. Okay, I didn't execute this code. Now I see I'm getting an accuracy of 50% on scale on the scaled data, and on unscaled I'm getting around 17.1%. Now on a tree based model, let us see what happens on a scaled data. I'm getting an accuracy of 66.79%. Now on unscaled tree-based model, I'm getting an accuracy of 66.87%, which is quite similar to this. So you see, again, scaling doesn't have any effect on a tree-based model we see here, and for the for the linear-based model, we see it has quite a this answer is almost tripling now when we use a scaler. So scaling does have a really big effect on linear-based models. Okay, so thank you for watching this, and in the next lecture we'll be looking at power transformer.